Hello everyone, this is the video lecture for Calculus 1, section 2.2, limit of a function. Or maybe limits of a function? I don't know. Limit of a function, that's what I got, so let's go with that. What is a limit? Well, here we go. Capital L is equal to, I have LIM, a little LIM, and then I got an X, and then I got an arrow, and then a little A. And then I got an f of x right beside it. Cool. This guy right here is basically our prototype for the remaining chapter. All of chapter 2 is really devoted to limits, so here we go. So when you see the little LIM, that means limit, and then I have this x and an arrow to an a, that means x approaches a. X approaches a. Of f of x. So I would add the of f of x kind of thing. So this is the function that we're applying this limit to. We're looking at this function x. I mean, I don't want to say equals. I'm going to just say kind of equals a, and we want to figure out what's going on. So a lot of times what happens is that you could just say, well, it's f of a. I want to say that x is equal to a. I want to say that. Again, this is very rough. X wants to equal a, and so I got f of x. Well, what's the answer is f of a. Haha. So just really a silly example, if that's okay. I got 2x plus 3. Very basic stuff here. And I say, well, find the limit as x goes to 1 of f of x. So yeah, x is going to 1. Let's just, again, I'm being silly here. Let's just say x equals 1. Let's just say that. And so what I want to do is I want to take the x and plug in a 1. And oh my goodness, I've got 2 plus 3 is equal to 5, and that's your answer. That's your limit as x approaches 1. That's it. Wow, that's all it was? Yep, pretty easy. So I'm just going to say plug it in. All right, cool. If it were that easy, and just that easy, then we wouldn't have to talk about it for a whole chapter. So I'm making it deceivingly easy to you, okay? It's going to get a little bit more tough, and I want to show you all the different things about what limits are. But at its most basic core, I want x to be whatever that is. And a lot of times I could just plug it in and get a number. Now, when I say a lot of times, I'm not really meaning on your homework. I'm saying in general with a function that, it's just a basic function, okay? So what do we do here in calculus? Why is it any different? Why can't I just plug it in every time? Well, let's talk about some different stuff with limits and kind of go from there. I also want to show you graphs. Let's start with limits from different sides. And this is actually in the college algebra class. And can't remember what they call it. Arrow notation, I think. Arrow notation. Regardless, though, this is something you should have seen before. But yeah, I'm not going to teach it like that because that would be silly to me. I'm just going to assume you've never seen it before. So this is the same limit, but notice here I got a little negative sign up in the power there. And this means from the left. And the little positive sign up in the tower means from the right. Those are what those mean, the little negative sign and the plus sign. When I'm wanting to get to this A right here, and I'm approaching it this way, this is from the left side. I'm just going to write left. This is from the left side, and over here, this is from the right side. Notice that, if I divided it right here, left, right. I mean, you're just looking at my hands here. I got my left hand and my right hand, and that's what's going on. I'm not saying that's it's pointed to the left or anything. That's not what I'm saying. I'm saying that it's actually just on the left side or it's on the right side. That's all it is. Now, what happens is that we're looking for this limit as x approaches a with nothing. And so this is like an actual limit from both sides. In order to know what that's going to be, I need to actually do both the left side and the right side. And so I would have my limit here, and I have my limit there, and I look at them and I say, aha, that's my answer, because they should be the same in theory. So let's go through some graphical representations of these guys. I'm going to show you the differences and visualizations and stuff like that. So let's just do a nice little cubic here. Cubics are really cool. And I got right here is my A is my X value. It's an X value. And so I have a point on the graph right there. And I want to know what that point, the height is in a way. I want to know what the limit's going to be. So how this works is that I come in from the left and I come in from the right. And you can see that we're approaching the same on both sides, the same point on both sides. And so whatever the answer is for both will be my actual limit answer. I'm going to read you what I have in my notes here. So I have my little picture here, and it says, a true limit comes from both sides. Each side must come to the same point. So there you go. So we're getting the same number, and therefore you're going to get that limit. So it's kind of like saying the limit as x approaches a from the left side of f of x is equal to, let's just make up a number here if that's okay. Let's just make up 2. And then I got the limit as x approaches a from the right side of f of x is equal to 2. And so you can notice that both of these numbers are the same. So when I say, hey, what's the limit as x approaches a? Again, on both sides, because it didn't have a little thing there, so it must be both. You would just say the answer is 2 because, well, they're both the same number. There you go. Pretty easy. Let's move on. So here's another one. I'm trying to make this look a little bit better than that. Let's say I have a vertical asymptote, and I have one side doing this, and I got another side doing that. And again, this is A. That vertical asymptote's at A. Well, notice here on the left side, this is left, this is right. Keep that in mind. And this vertical asymptote's nicely dividing that for me. Here I'm going up to positive infinity. Here I'm going down to negative infinity. And I'm going to say, is positive infinity equal to negative infinity? Are those the same values? Is 2 equal to 2? Are those the same? Yes. Is positive infinity equal to negative infinity? No. So no limit exists for this kind of graph here at A. No, well, I don't want to say limits. No limit. It's just done. There's nothing to talk about. What's the limit of blah, blah, blah? You're going to say no limit, or maybe undefined, or something kind of like that. It kind of depends on the problem. WebAssign will probably say, you have to type undefined. And that's fine. You can do that. I have a little note here in my notes. It says, here we will get 2 different answers, thus no limit exists at that particular point. So no limit exists. There's a proper word there for you. Undefined, I don't really know if that's a true thing, but the point is that it's not, there's no limit. So we move on and we don't talk about it anymore. Here's another example. Let's say that I have this kind of graph here. Okay. Now notice that I have an open circle and then a solid. And so this guy here is closed and open, and he's not touching, and he is touching, and da-da-da-da-da. So, and this is at A. Obviously, it's my point of interest here. And so on the left side and the right side, I wanted a different color. Hold on. There we go. On the left side, I'm going to this point right here, this y value. And on the right side, I'm going to this point right here. And they're different. I don't know. Let's call this one 3. Let's call this one 1. So is 3 equal to 1? No. So no limit. Undefined. That kind of stuff. Now, I know that this actually is an open circle, so you can't actually touch it. And this is a solid, so you can touch it. That is not what I'm asking about here. I'm only concerned about limits. And that means direction and all this stuff. So where am I going to be approaching? Where am I getting close to? Yes, I know it's open, but just think of it like closed for now. No! I know mathematically you shouldn't. My point is that you're just trying to get over to this area. What would it look like? Just give me the straight human answer. What's your height? It's 3. Going this way. What's your height? It's 1. Are those the same? No. So therefore, no limit exists. I have my little note here. It says, same here, 2 different y values. All right, and I got one last example here, visual sample here. I don't think my graph's super awesome, but here on the left side and on the right side, this is A, by the way, you can see I'm going up to this point, and I'm just going to label it, let's call it 4. So we're going up to a height of 4, and on this side, I'm going up to a height of, oh, I don't know, 4. So 4 on the left, 4 on the right. Are those the same number? Yes. Those are the same numbers. So the limit would equal 4. Blah, 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 whatever else little particulars in there. Notice that they're both going to the same number. Ta-da! Now, I want to actually change this just a tiny, tiny, tiny bit right here. And I want to show you something kind of funny, how this also could be modified. What if there's an open circle here that they're both going to, but then I have a solid right here. And I say, hey, find the limit. And I don't know, this height right here is at 2, let's say. So I got this side coming up to 4. I got this side coming up to 4. 4 and 4, they're the same. Yes, so the answer's still a 4. You're saying, but hold on, that's an open circle. You can't actually be at that point. So the function value at A, in this particular case, would be 2. But I'm saying that the limit as x approaches A of f of x is equal to 4. Okay, we're only talking about the limits things. Yes, if you said plug in a point and you would get a point, you get a 2, I totally get it. That's fine. We're going to see that on the homework here in a few minutes. But I'm asking about approaching. I'm wanting to get close to. Again, I like to use my hands in class, but the point is that I'm trying to get close to this thing on both sides, not actually touching it, not needing to touch it. All right, that was a lot of jibber jabber. Let's actually do some homework problems now. So 22004. And just as a reminder, this is not number 4 on your homework. It's probably number 1 on your homework, but I don't know. That's just the identification number they use. So I have a graph. It goes until this point here at 2, 3. And then I have an open circle here at 2, 1. And then it comes up, and then I have an open circle at 4, 4, not to scale, and then it comes down. So not to scale, I'm just kind of going with what they got here. Let me give you some values. So this is at 2, and that's at 4, again 3, 1. Yeah, that's good, close enough. Okay, so we got this graph, and they say part A, find the limit as x goes to 2 from the left side of f of x, of course. All right, so I'm wanting to get next to 2. So 2 is my key number, and they say the left side, and so I'm going to be over here. Again, you can kind of think of this as just being divided here. I got my left side, I got my right side. So I'm on the left side in this particular case. I'm following the graph, and then I'm trying to hit up that point. So what's the height right up here? If I keep going this way, and I'm wanting to hit that, 2, I hit the fence. What was the height whenever I hit the fence? Well, the height's a 3. You can see right there, it's the y value, 3. And then we're done with that. That was it. Wow, that was pretty easy. So the next one says, hey, find the limit as x approaches 2 from the right side. Again, notice that we're talking about here. I'm trying to change my colors every time I do that. My right side. And so I'm going to be on the right side this time. And starting way over here, doesn't really matter, whatever. I'm just going to come on in, and I want to hit the fence. Boom. What is the y value when I hit the fence? It's right there. It's 1. Awesome. So then they say, hey, what's the limit as x goes to 2? They're wanting now both sides. Well, here's the thing. I got a 3 and I got a 1. So are those the same number? No. So, no limit. And I actually have the official answer here. It's not no limit. The official answer is DNE. Does not exist. You type DNE, you hit the enter button, WebAssign says, great job, and you move on. So that was pretty cool. Part D says, hey, find f of 2. So they actually want the height of the graph at 2. So if you remember, I already drew all over it, right here there was a solid, and right here there was an open circle. The solid, of course, is the actual value, the actual y value at that point. So when we plug it in, we get that 3. So that's important to see. Part E, it says find the limit as x goes to 4 of f of x. Looking over here, 4 is this guy, so you can see we're coming in from both sides. They look like they're going to the same point, which is good. What's that y value? It happens to be a 4. Yay, done. Nothing else to do there. And then finally it says, hey, what's part F? It says, hey, what is f of 4? So what's the actual height at 4? Well, this was an open circle. Do you see any solids anywhere? Exactly. So there is no solids. Therefore, there is no defined value here. So your answer is DNE. In the box, you actually type DNE, you hit enter, and you get it right. That's how it works. All right, cool. Next question, 22009. This one is a big problem. I got all kind of graph going on here, so I'm going to try really hard to make it look good. So at -3, I got this this vertical asymptote thing. At -3, it does something kind of like this. And then at 0, I have another vertical asymptote, and it's doing something kind of like this. Oh, hold on. It's something kind of like this. And then I got this cubic-looking thingy that does all this business here. And that's over here at 6. And then finally, I got this going on over here. Wow, that's a lot. Okay, so part A, they say, find the limit as x goes to -3 of f of x. So, -3 is right here, and I'm looking around and seeing what the answer is going to be. So on the left, this is both. Remember, this is both here. So on the left side, we're going up to positive infinity. On the right side, we're going up to positive infinity. And I'm going to ask, is that the same answer? And, yeah, positive infinity. So guess what the answer is? It's positive infinity. I believe that you can type the plus sign and then the infinity and it'll still accept it. Or you could just type infinity and it'll still accept it, obviously. I'm just trying to denote it or differentiate it from a negative infinity, which we might have just in here in a few seconds. They say find the limit as x goes to 0 of f of x. So I'm looking at 0. 0's right here. Notice that we're going up. They're both going up. Positive infinity. Yet again. Cool. The limit as x goes to 6 on the left side. So beware. Remember, see this little negative here? That means left side. Left side only. And so left side over... Is it 6? Yeah, positive 6 on the left side. This is left side. This is the right side of 6. And so we're going down, 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 aren't we? Down is a negative infinity. But then on the right side of it, you already guessed that I was going to be doing that. On the right side, it looks like I'm going up, 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 positive infinity. Cool. And then finally they say, list the vertical asymptotes. And this is super easy here, of course. You're just going to look around and say, right here. -3, 0, and 6. -3, 0, and 6. That's it. That was not too bad. Next question. 22005. Didn't we just have something else? 009, now it's 005. I don't make this stuff up. I'm just going in order with the homework. So again, this could be number 3 in your homework, could be number 5, it could be number 10, I don't really know. But I'm just going in order here. I have the limit as x goes to 0 on the left of f of x is equal to -1. Also, the limit as x goes to 0 on the right of f of x is a positive 1. And then it says f of 0 is actually equal to 2. So here we have left side, right side, and then like a point, I guess you can say. So those are my little interesting things there. And they say, what's the graph of this? So it's a multiple choice, of course, and we need to figure out which one meets the criteria that you see here. Notice that here on the left side, we're going to -1. So everything's always centered around 0, if you can see that, 0, 0, and 0. So 0 is like my important number that I'm trying to get to. And on the left side, this is my left, this is my right. On the left side, I'm trying to keep going towards the 0, and it hits -1, which is like right there. And this up here, let's call that +1. We'll do that here in a second. On the left side, blah, blah, blah. And boom, we're going to try to hit this guy. Now, here's the thing. I don't really know what's going on exactly there. I'm just making little squiggles. This thing could be like whoosh, whoosh, whoosh. But eventually, the snake is going to try to hit this little point right here, okay? So just keep that in mind. All kind of wiggles. I don't really care as long as you're trying to hit that point. On the right side, we got snake wiggles. Maybe I need to make it a function, so it's going to not be overlapping. Eventually, it'll try to hit the +1, okay? Because we just saw that +1 right there. Awesome. But it just so happens that neither of those are actually a point. The point itself is at 2. And so let me erase this box because it's kind of getting in the way. You might be thinking, well, don't you have a more professional eraser than that? Probably. I haven't really looked. But this is going to work. It's good enough. It's out of the way. Okay. Good enough. So there's an actual point here at 2, and yet here there's no point, so it has to be an open and an open in order for this to actually be a function. There's only going to be one point here at all. So pick this kind of graph. I don't know what kind of wiggles there's going on, but that's pretty much what I have in my notes. 22019. So it says the limit as x goes to 4 of x squared minus 4x all divided by x squared minus 16 is equal to what? Is that what they're looking for? Use 6 decimal places. Right. Okay. Let's you and me pause and talk about this for a second here, okay? Is there a way to do this problem non-conventionally? And then is there a way to do this more conventionally? If we go back to our concepts of the secant lines from the last section, if you remember, they started us saying x equals 2 and x equals 1, but then they said x equals 1.1 and x equals 1, and then x equals 1.0001, something kind of like that. We're trying to approach these same things so that, well, they overlap and make x equals 1. So that's kind of what I'm getting with here. And I'm going to try to do the same style for this. So we want 4, and so guess what I'm going to do? I'm going to do 4.1 and see what happens. So instead of actually plugging in the 4, because that's not going to work if you can kind of see, I want to plug in something really close and see if we can get something kind of similar. And this is kind of the hint that says, hey, we're just guessing here. If they're doing decimal places, they're just guessing. And so I'm going to be guessing as well. Let's use x equals 4.1. That's what I have in my notes. Let me just show you what happens here. So 4.1, that's the ugliest 4.1. Hold on. 4.1. Okay, so I got 4.1. The decimals are harder than you think to draw here. And then I got a 4, and then I got a 4.1, and then all divided by 4.1 squared minus, again, just the 16. I'm just getting really close. I don't really have that exact number. I'm just getting really close, 4.1, and I plug it in, and I got a 0.506173. Now, they might have actually asked for that at 4.1. I can't remember. My notes do that, and that's fine. Let's try 4.01. So I'm going to do that now. And you can probably guess how this is going to work. You plug it into the calculator. Because why not? And now I got 0.500624. If you keep going with 4.00001, eventually you'll see that you get the 0.5000000000. Yeah, it's whatever. So it says 6 decimals. It's good enough. Looks great. We like it. So 0.5 is going to be the answer. Now, that is the manual way. Is there another way to do this thing? Yes. Let me show you. This is kind of like not in my notes, and that's okay. I just wanted to. I just saw it and I said, you know what? I bet we could do something different here. what if I factor out an x from the top? And what if I factor the bottom to be a -4 and a +4? And so I'm just looking at this function here. Well, guess what? These guys cancel. And so we got x over the x plus 4. And what they're really wanting now is they're saying find the limit as x goes to 4 of x over x plus 4. Guess what I'm going to do? I'm going to actually just plug in the 4, not 4.1, not 4 point blah, 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 and all that kind of stuff. So I got 4 over 8. And yes, guess what? That makes 0.5, which is exactly what we got up above. And wow, that was so easy. So in a way, I'm going way back to the very first example I did, like literally the very first example I did with you. I said, guess what? What are we going to do here? We're going to plug it in, and I did, and it worked. The thing is that I had to do a little bit of simplifying first. So you think, well, I never need to simplify. Here in WebAssign, it does it all for me. Yeah, but like, look, obviously we need to simplify it and we can get some easier answers. Just a thought. I don't know, just a thought. Again, that's not in my notes. I just thought that would be a cool thing to talk about here. 0 to 5. And so this one's different because it says the limit as theta approaches 0. So theta is like angles and stuff. And sure enough, they're talking about sine of 5 theta divided by tangent of 2 theta. And they're saying find out what's going on there. So you could try to simplify this thing down using the pre-cal. It's not worth your time. I can't even. I think it's trig identities. Yeah. So pre-cal trig identities, totally not worth it because that would take forever. Notice that we're trying to get close to 0, and in the last problem they were saying just use an approximation. So yeah, I'm gonna do something kind of like 0, 0. Hold on, 0, 0, 0, 1. You can put as many zeros as you like. It don't matter. As long as it's getting really close to 0. And radian mode. Make sure you're in radian mode. I plug it in. So I'm plugging that in to those guys there. And my limit turns out to be a 2.499999999. And I'm just going to wonder. I'm just going to guess. Hey, what's your answer? Oh, I don't know. 2.5? Yes. I have 4 more questions, but they're kind of more like rapid fire ones. So let's just get these done and then we'll be done. So limit as x goes to 0 on the right side of x cubed times ln of x. That's strange all of a sudden. Notice that we're on the right side of 0, and so we're wanting to stay like, if you're looking at the number line here, that is a terrible number line. If you're wanting to look at this number line, we got a 0 here. We're wanting to be on the right side. This is where we want to be. And I want to come in close to 0, but I don't want to actually be 0. If you plug a 0 in here, it's not going to work. But I want to be on the right side. So, I don't know, 0.0001. Notice I don't want a positive value. I want to be on this right side. So I'm using a positive 0.0001. Okay? I'm going to plug that in. And we're going to get a value. And so when I plug that in right here, I got negative 9.21034 E negative 12. And if you ever see this on a calculator with this E negative 12 business, what they're trying to get at is that you got a 11 zeros before you even get any significant digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11. You don't go all the way. And then you got the 921034. Okay, so I'm going to ask you here, take this value here. I'm going to round to, let's say, 4 decimals. That's a pretty healthy number, right? Round to 4 decimals. What's your answer? It's 0. Hey! You did not have to go and do all that. Yeah, you got to plug it in. But you don't have to go through all this. If you see this right here, it's 0. 22029. I've got the limit as x goes to 1 on the right side of x plus 6 over x minus 1. Again, I'm just going to use something that's on the right side of 1. Notice my number line 0. There's a 1. 1 is my important number. I want to be on the right side of it. And so I'm going to choose a number over here, 1.001. That's good enough. So that's what I'm going to choose. I'm going to plug that in, and we're going to get a value. And so I do 1.001 plus the 6, 1.001 minus the 1. My answer was 7,001. Now, this is an interesting thing. 7,001 is really high compared to all this stuff here. And I don't really know what to do. So, hey, what if I plugged in a 1.0001 and see what I get? I don't know what you're going to get, but the point is that when you keep going closer to 1, you're going to get closer and closer to positive infinity. Now, here's the thing. Could you actually have an answer of 7,001? I mean, yeah, but like I'm looking at this and saying, well, that's not a simple number. Like, look at this. This is your question. Did you expect 7,000? I didn't. So it's already kind of suspect that, what are we getting here? What is this actually trying to say? It's trying to say that we're going towards positive infinity. In a way, an infinity is a concept. It's not a number. And so I'm dealing with, and let's just put this in real world terms, I'm talking to like $6 and then like $1. So like in your wallet, I'm like, hey, how much dollars do you have today? And you pull out your wallet and you're like, I got $6 here. And how many do you got? I got $1. And you're like looking around. I got enough for a candy bar, I guess. That's cool. Yeah, sure. And then somebody pulls out their wallet and says, well, in my wallet, I've got $7,001. Well, first off, whoa, that's crazy. Don't walk around with that. But at the same time, that's enormous. Like the people with $6 and $1 are saying like, that's infinity. That's crazy huge. And just for, cash in your wallet kind of thing. So I guess in a way, infinity is a concept. And so when you're getting these really big numbers that were unexpected, it's an infinity. Okay. 2.2.035. I got the limit as x goes to pi over 2 from the right side of 8 over x times secant x. Same thing here. Notice that we have this pi over 2 and we're on the right side of it. So we have pi over 2 on my number line. I want to be on the right side, so something over here. I don't know. Is it like just pi? Is pi close enough? It's on the right side, isn't it? I mean, we got pi over 2. I don't know. Pi over 3 is over here. Pi? Pi's, I don't know. 2 pi over 3. How about that? That's pretty awesome. No. No, 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 no. You want something really close. So I want to be like cheater, pumpkin eater here, if that's okay. Watch this. Pi over 2 plus 0.001. That's good enough. I don't know what this number is. 1.571. There you go, because this is pi over 2, and there you're going to add a little bit to it. Don't use that number. Use this. But my point is that it's super silly. That's okay, because we're just wanting to see what would this be. Just a tiny, tiny bit on the right side. So multiply. We got secant of, again, pi over 2. I'm showing you. This is not in my notes here. I'm showing you because I want to say this is what I'm putting in the calculator. Literally, exactly as you're seeing it. I'm not trying to make it weird. I got a negative 5,089.718. You tell me. Were you expecting a negative 5,000? You go into your bank account and you're like, hey man, I don't know, I probably got $1,000 in there. I got a couple $100 or whatever. And then it says a negative $5,000. You're like, what? Yeah, that's something crazy. Give me an answer. It's negative infinity. It's negative infinity. This thing is crazy compared to like $8. I don't know. I'm trying to make the concept here. I'm trying to show you that when you get these ridiculously crazy huge numbers, it actually means something. It means infinity. So 4242. Y is equal to x squared plus 1 all over 7x minus 2x squared. And they want to know what the vertical asymptotes are. I guess. So how do you find a vertical asymptote? Is you take the bottom and set it equal to 0. And so 7x minus the 2x squared is equal to 0. And then you start solving. You can factor out an x. So we got x equals 0. And here we got 2 over 7. No, 7 over 2. Okay, there you go. So those are your two answers that you're going to put in the box here. 0, 7 over 2. And then they say find the graph of this thing. So I'm going to try to make it not as sloppy. 0, here's 7 halves. And the graph looks something probably like this. Again, I'm not being super cool and interesting with it. Just pick the one that does the vertical asymptotes like that. So that was it. That's all I got for that section. So we're done there. Thank you very much. Have a great day.